Well, my name is Guido. I work at Wormhole Foundation. We have two contributors. I'm the technical projects lead. I work mostly with large integrators and institutions that want to bring assets cross-chain. What I'm going to talk about today is how Wormhole works with different blockchains and how to assist in different use cases. But first, we can start kind of explain why we need these connections and why blockchains need to be connected in the first place. Well, first, in the case of internet, what we had, was people wanted to send messages to each other. We started with transatlantic cables. It started little by little, and currently we have hundreds of connections between countries, continents, and so on. With the current increase of blockchains, as we can see here, over the years we have more and more blockchains. You can see now how easy, you probably saw it in previous lectures, how easy nowadays is to spin up a new blockchain. You can do that in, I think someone said, 10 minutes, 15 minutes. So you can imagine the importance of connecting those blockchains, because even though it's good to have new blockchains, you also want to do stuff with them. You need to bring assets, you need to bring users, and that's where we're trying to help. In the past few years as well, apart from these blockchains, what we've seen is how liquidity has been moving from centralized exchanges to the DEXs. Probably most of us know about the 2020-2021 craze. New coins, we're all expecting a new one shortly, but it's undeniable the amount of on-chain transactions, swaps that we're seeing even so more often. Okay. So, what can we do with blockchain interoperability? I mentioned on this the beginning. So we can bring new users to new existing users to new chains. We can make people who are using, for example, Ethereum, they can take their funds to another chain. It allows to access those funds not only for users but for protocols. Say you have USDC, you want to use that not only on ETH, you want that everywhere, because you need stables everywhere. And day to day we keep finding more cases. I'll mention a few more in a little bit. Okay. So does Wormhole do everything on its own? No. What we do best is passing messages. People always relate Wormhole with bridging. No, that's just one of the things that we can do with these messages. So we're kind of the foundation of how we think of blockchain. On top of that, you may see applications like bridging. We use the Portal bridge. Maybe some people here have used it. We have USDC. They have their own CCTP implementation. Also, we work with them on a few other chains. We have Mayan. Some people may have heard of Intents. Those are also technologies that work on top of Wormhole. And then on top of that, you can have aggregators. You can have Li-Fi socket. What they do is use the liquidity and protocols underneath to sort of combine and find better routes. And on top of that, of course, you have your wallets and your user layer, where people can interact with all these protocols. So, why is it difficult to do cross-chain, and why can't anyone do it? Well, first, there's a lot of security considerations, right? We've seen a lot of hacks from people doing volumetric bridges. some cases again, if you think of, for example, the Ronin Bridge, that was a very famous one, and there's a large amount of cases why security is paramount. Decentralization, because obviously you don't want a single person, organization, or entity controlling all the rules for moving those funds. What we do, for example, is have a set of guardians, which are kind of validators, and we distribute them among at least 19 trusted organizations. And all of the code is open source and verifiable, so that anyone can have a look, find issues, report them, and make sure that what we're running is what they would expect. Also, the scalability issue. Scalability is paramount. You want to move like millions or billions of dollars. You cannot have something that doesn't scale. And obviously, user experience. You want to make it easy for the users to move funds around. If not, what's the point? They'll just go to their bank. So a few of the things that I mentioned about why it's secure. In our case, we have bug bounties. Those are open, anyone can check them. Like if you find something, you can get a bounty. In our case, we do a lot of audits. We have contributors from Wormhole that work on these audits, but we also get external firms to do this for us. And we also take very serious assessments from other protocols who may want to run their own assessments. Uniswap was made actually a very large one. I think it was a couple of months ago. I'll talk about that a bit later. Let's see. So a few more use cases. What you can do cross-chain. The most important, the main one that comes to mind is obviously token transfers. Is simply moving tokens around. We have various ways of doing that. One could be the portal bridge. We have a framework that I'm going to explain shortly called MPT, and also recently, like within Tense, we have released a new protocol called Wormhole Settlements. I'll explain that shortly. Another thing you can do is borrow and lending. We have a few integrators that have done a few nice things with that. They have protocols on one chain and lend to different chains. NFTs, Ethereum, I'm going to show now in a little bit an example. But say if you mint an NFT in one chain, you may have a use case in another chain, and you don't want to do that like repeatedly. Why not just have something that can interact with it cross-chain? Oracles, also a big use case that we have with Wormhole. For example, if you want to know the price of an asset on a different chain, how you do that? Well, I'm going to explain that shortly. Governance, also a very good use case, and that one has been used by Uniswap. So you know how like you have your tokens on your base chain, but you also distribute them to other chains. So how do you have a secure on-chain protocol that considers all of that? We have a tool called Multibus that what it does is that securely collects the votes across all chains and then does the final tally on the main chain. Another use cases could be identity swapping. This is the one I was talking about just now. Governance. You can see like it covers a lot of chains. What else? Well, here you can see a bit more how things work on our portal bridge. Another way of using this for swapping is using Wormhole Connect. We have a widget of information, very simple to use with like 3 lines of code. You can use that on your protocol and spin that up in no time, and have your users move your token or token that you may need very simply. Well, as you can see, there's like a wide adoption for this. A lot of transfers daily. If you wanna have a look at what people are doing cross-chain, I also recommend you go to wormholescan.com. There you can find this kind of like a blog explorer, but for cross-chain. It's very interesting, and you can see a lot of these. Okay. This is one of the most important products for us. It's called NTT, Native Token Transfer. So, what does NTT try to solve? You know how you may have used native bridges, or there are a few things that you can do with some frameworks. For example, and also this happened with Portal Bridge. If you need to have a token with custom logic, generally what projects do is like they deploy it on the main chain, and then when they use a bridge, what they get is like they get an L2 token that's very limited. It's generally owned by the bridge, and it doesn't help like very well when you need to do stuff with it. And because in most cases, like protocols don't control the token, and they might need to do things with that. So what we do with NTT is let the projects deploy their own token on all the chains, and this framework, what it does, it's not another token standard. What it does is it's a manager that connects to all the instances of your token, and when people need to move them around, it creates the token, or it mints the token, or it burns them, like according to what users need to do. Or in the case where that's not possible, users move tokens to the bridge, they get locked, and they get minted on the destination chain. It's open source, it's composable, people can make changes if needed. We have integrators that have, customize it, and it also works with governance. Yeah, so like I was saying, we don't know the deployments. Everything is owned by the protocols. It has security features like access roles. It's possible. It has very limiting if you don't want to allow your users to move big quantities at the same time. And it's all verified by our network of guardians. It is also possible to have M of N verifications. So if protocols want to use their own verifiers, they can also do that. I mean, they can customize it at will, but that's also a feature that some people like to use. Another product that projects have been asking for a lot is one-hole queries. When I was talking about oracles, mainly what you can do with this is use our network of guardians to query about data on our blockchains. So say you, like I was saying, if you want to know the price of an asset on another chain, but don't want to run multiple transactions or bring the data from an untrusted source or off-chain, you can ask our guardians. They'll sign the data, and then you can use it for your own purposes. Like I said, for price feeds, different kind of things. Another tool people use a lot is, like I think I mentioned this one, Wormhole Connect. It's used to like with free lines, deploy it in your front end, and move tokens around easily. Another very good use case for this is for gas drop-offs. So if you're working with a new chain and maybe your users don't have gas there yet, apart from breaching your tokens, you can leave some gas there for them to work with. If I can play it, let's see if I can play it. Yeah, let me show a bit how it works. So yeah, you can choose the from network, choose your 2 network, pick a token. You can add more, like you're not just limited to the default list. From there, simply they can choose how much gas they want to receive, and very shortly they'll get their tokens. All right. So apart from all of this, what are we working on as a company? One of the things that we want to bring in is CK proofs. We think that is like the end game for cross-chain security. It will allow us to go further with doing stuff on-chain. And before I finish, let me see if we have time. I wanted to show you how to use NTT to do something a bit more practical. One second. All right. So for NTT, we have different ways of working. This was a product we released very recently. We generally have been recommending projects to use the CLI. You can get that from our repo. But like for simple cases, I wanted to show you how easy it is to get this working. So what I'm going to do is to get started, and I'm going to quickly launch a new cross-chain token and show you how easy it is to do that. All right. So let's see. I have my wallet connected. I'm going to deploy it on base. Let's call it crecimiento. We give it some supply. And now we can choose which networks we want to deploy this to. I'm going to do just one. The beauty of it, you'll see later, you can manage and add more when you want. So I'll just do Arbitrum as well. So I'll deploy this, sign the transaction, boom, there we go. Okay, now we've deployed. Now that it's confirmed, I'll just go to Arbitrum, deploy the second token. Remember, these are native tokens, so I have to deploy them separately. It's not like I'm taking one and breaching it. Like, these are native. Boom, there it is. And there on the dashboard, you can see the address. Let's see if I can see it. Well, thank you, Basecamp. Always a pleasure. Well, at least here you can see where it is, if they have limits, and you can configure them. So polybase. You can add these thresholds that I was talking about. You can see if there's limits. Let me see about Arbitrum. There it is. Okay, and you can see it's on Arbitrum as well. Since I'm the owner, I can choose to pause it. But let me see if I can open it, at least on Arbitrum. Yeah, you see it. Obviously, you can use your own token contract. But in this case, for the web UI, to deploy a new one, we have a standard version. Let me see if I can have some methods just to show you. Yeah, the usuals. Okay. So apart from this, okay, now you can see both chains. Apart from this, obviously you can. Let me see if I can go to the main page. Yeah, you can Also, like if you have an existing token, you can go via the UI, add the address, and create deployments on multiple networks. It's really very simple to use. Obviously, for more advanced use cases, I suggest you go to the native token transfer repo on GitHub. I'm happy to send that to anyone. You can find it very easily. And another thing that I wanted to show is like a more raw use case, which is sending messages between chains. So here I have an example repo that shows how to send and receive messages across chain. So what you would do in this case is on one chain, you would set up your message sender. Let me see if I can explain it a little bit. So you would create it, passing it the address of the one-hole relayer for that network. You can find those on our documentation. Each network has its own. So what you would do is on the send message function is give a target chain and a target address. The address would be the one of the recipient contract. And you can, in this case, for this example, we're passing a message.
The size of the payload is not relevant.
In this case, it's just a text message, but you could pass, for example, parameters for a function call on a destination contract. I'll show that in a bit. I have a more advanced example. So in this case, what it does is it gets the cost of passing that message to the destination chain. It makes sure that the funds are passed. It's a payable function, and then it sends the payload to the relayer. Here you can see that it's encoding the message. And that's it for the sending part. Now on the recipient part, here is the example receiver. Similarly, you begin deploying that with a trusted relayer address. There's a few security considerations that you may want to have, like to register who's able to send, because obviously you don't want to process messages from anyone. And let's see, and here would be the main part to receive the message. The relayer calls this function and passes the payload that you sent from the origin contract. So it'll do some verifications, like I said, to make sure that the senders can do that, and the message comes from the relayer. And in this case, what it does, it decodes the payload and it extracts the message. And finally, for this very simple example, what it does, it emits an event, which is the string that we send from the origin. So this is the simplest use case for sending stuff cross-chain. Let me see if we have an example. Let's show that now. Yes. So if we go one step further, what else can we do? You could allow minting an NFT on a different chain. So here I have an example of a store. What this does is it. Let me see if I can go to the main part. Let's see. There's a function. Okay. Well, let me try to explain. So it's a bit longer, this one, but okay. So what this does mainly is it takes a payment from a token defined by the deployer. You can see here how it transfers the token. So this goes to a treasury on a source chain, and then let's see, it calls this send cross-chain mint instruction. I'll show you that in a bit, which does something very similar to what we saw before. So from the contract, it depending on what the user called, it grabs an NFT type, an ID, and it sends that to a destination chain. So you can see the address in this case is the same of the buyer. Then on the destination chain, let me scroll down a bit. Okay, you will have like the receiving end. So on the, just to recap a little bit, on the source chain, you have your store, you receive the funds, you send the message to mint the NFT on a destination chain. Okay, so now you receive the message of the purchase confirmed by the origin contract. And here we go. Here, you decode the instruction. So this is kind of like what someone there was asking before. So you can decode the message for whatever purpose that you have. In this case, you get the buyer, you get the NFT type, you get an ID, you get how many NFTs you want to mint, and then use that instruction to talk with an NFT contract and mint the NFTs on the destination chain. So there you have like a end-to-end purchase process across two chains. This is just another thing that you can do that's a bit more different than maybe just bridging tokens, just to put another example. So, well, I hope you like the talk and I didn't go too fast. Thank you.